Hello, this is Diana Hayden, the Climate Focal Point at the National Weather Service in Pendleton. I will be talking to you today about the new climate normals produced by the National Climatic Data Center, or NCDC, in Asheville, North Carolina. This briefing will cover why new normals are calculated and briefly about how they are calculated. The World Meteorological Order mandates that all countries calculate new climate normals every 30 years for a 30-year period. They recommend that all countries recalculate normals every 10 years, which is what NCDC does. The previous 30-year period covered the dates 1971 to 2000. The new normals include the dates 1981 to 2010. Many different organizations benefit from and make decisions based on climate normals. Some of these organizations include utilities, renewable energy companies, agriculture and insurance, civil infrastructure and construction, academic research projects, and the general public. There are two different types of normals produced by NCDC. The core normals are the most widely used normals as identified by NCDC and other climate partners, such as the National Weather Service. These core normals include monthly station-based normals of temperature, precipitation, snowfall, snow depth, and heating and cooling degree days. This information is now available on the National Weather Service website. It is located under the Climate tab and is called Now Data. Each Weather Service office will have normals for most of their cooperative observing stations. Supplemental normals include all the other normals calculated by NCDC that are not released with the core normals. These normals include population-weighted degree day normals and freeze dates. Many of these normals were not released until later, as further data was needed for the calculations. For example, the population-weighted degree day normals were calculated when the U.S. Census Bureau released the final population numbers. Weather stations must have at least 10 years of data per month to obtain normals. The 1981 to 2010 climate normals will include normals for over 9,800 stations. Temperature-related normals are reported for 7,500 stations. Precipitation normals are provided for 9,300 stations. Snowfall normals are provided for 6,400 stations. And the snow depth normals are provided for 5,300 stations across the United States. Data from the cooperative and network stations are used to calculate the monthly temperature normals. The monthly values are the first calculations completed. The missing or suspect values are filled in using a regression technique based on the neighboring values. Once all the monthly values are filled in for 30 years, the monthly normals of maximum and minimum temperature are computed as the simple averages of the 30 values for each station month. The monthly average temperature is then computed as the mean of the monthly maximum temperature normal and the monthly minimum temperature normal. For the daily normals for maximum and minimum temperature, a constraint harmonic least squares fit is used. They are then checked against the monthly temperature values to ensure that the mean monthly normals are consistent with the means of the daily normals for a particular month. The daily mean temperature normals for a particular station are used in the computation of the degree days. Calculations are done to estimate the spread of daily temperature values about the daily normal. The values are then averaged to arrive at a normal value of heating degree or cooling degree days for that day. Monthly normals are then computed by summing up the corresponding daily normals. Annual heating degree and cooling degree day normals are computed as the sums of the 12 monthly values. Normals for precipitation are computed using cooperative and network daily station data. The 24-hour precipitation totals, 24-hour snowfall totals, and the once-a-day snow depth measurements are considered for the calculations. For precipitation, the monthly totals are calculated for every station, year, and month in the dataset. Missing values are filled in using a regression relationship between stations and qualifying neighbors. This is not done with snowfall due to the large number of zeros in the dataset. For each calendar month, the average monthly total then is the arithmetic mean of all the observed and for precipitation estimated totals available during the 30-year period. Also provided are average totals for the year, as well as for each of the seasons. These seasonal and annual averages are obtained by summing the appropriate average monthly totals. For the month-to-date and year-to-date totals, daily data is used to calculate the normals, and they are checked against the corresponding average monthly totals to ensure consistency. So now that we have calculated new normals, what do the differences tell us? One thing we must keep in mind is that climate normals were not designed to be metrics of climate change. While changes from one installment of normals to the next do provide some evidence of climate change impacts, one must keep in mind that there are other changes that lead to differences as well. These changes include differences due to relocation of individual stations, changes in the method of calculating the normals, and changes in the instrumentation at the individual station over the years. This concludes our briefing. If you have any questions, please feel free to contact me at my email, diana.hayden@noaa.gov, or you can refer to the National Climate Data Center at the above address. Thank you.